Hello viewer, you are watching LM TV. Welcome to Form 1 Physics, Introduction to Physics. This lesson 2. I'm your teacher Benjamin Makanda. Stay with me. Now before we start our lesson, we want to look at specific objectives that we will achieve at the end of this lesson. So in our objectives, we would like to look at the relationship between physics and other subjects. So at the end of the lesson, the learner should be able to relate physics, other subjects, and technology. How are these related? For example, how physics is related to chemistry, mathematics, biology, history, and technology. So once we come to the end of this lesson, you should be able to relate this. Now, something that we have to note about this is that when you look at chemistry as a subject, chemistry mainly deals with the study of salts, acids, and their reactions. So chemistry deals with the reactions and production and preparation of salts, acids, and how these reactions takes place. Then another thing that we have to note here is that physicists make use of the knowledge of the working of chemical cells and the working of the chemical cells. So this working of the chemical cells that is employed by the physicist is borrowed heavily from chemistry, from the chemical reaction that takes place. So chemical reactions generate the reactions, and then these reactions are now tapped by physics to help explain how a chemical cell will work. So that's how they relate. Now, the reason behind the various colors observed in most of the chemical reactions are explained by physicists. So various colors, how they behave. In chemistry, we learn about what we call paper chromatography. Chroma means color. Then how these colors are observed and how they behave, they can only be explained by physics principles and concept. For example, if you take a ray of light and pass it through water, the ray of light is splitted. It undergoes dispersion to give us various colors. These various colors are what we commonly call a rainbow. Rainbow is made up of about 7 colors, but this is just a ray of light that splits to give us those 7 colors. Now, the splitting of these colors, and for us to be able to understand them, can only be explained in terms, laws, and principles of physics. Whereas now the study of the color, chromatography, can be done in chemistry. That's how chemistry and physics relate at this point. So the other thing about this is that petroleum products are dealt with by a chemist, but the transportation of such products makes use of the principles of physics. So how petroleum products are dealt with in chemistry. You know, most of the petroleum products consist of the hydrogen and carbon as the key elements. So how they are made, how they are manufactured, and then how they are stored. Now their transportation is now done by physics. Physics explains how the transportation of such products can be made possible. So we employ the principles and the laws of physics to facilitate the transportation of the petroleum products that is manufactured in chemistry. Now, what of physics and biology? How is physics related to biology? And if you want to observe a cell, if you have done a biology, you want to observe a cell. Cells are very small and we cannot be able to actually observe them by our naked eye. We need to be aided. So what do you use for actually observing the cells? One of the common apparatus that we'll use is a hand lens. Yeah, you can use a hand lens. What else can you use? You can use a microscope, either light microscope. You can also use a very powerful microscope like an electric microscope and all those. How do these apparatus work? How do you understand the working of this apparatus? Where do we get the knowledge to help us explain how these apparatus work? All these questions can be answered when we consult physics. So physics will help us to explain how these apparatus are used in biology to observe cells and the growth in living cells and all that. So this is what we can say about the relationship between the two. Biologists require the concept of magnification using simple or compound microscope, which is a brainchild of physicists. Now, the working of a simple and a compound microscope is developed by physicists. They actually develop it and place there some basics that help it work so that we are able to apply it in terms of magnification and all that in biology. Like now in this case here, we have a sample of the specimen being observed here. Now we have the eyepiece. This eyepiece is made up of a lens. This lens comes from the knowledge of physics. So that specimen that we are observing is magnified, is made to look big, because we can actually be able to explain it when we apply physics here. That's how biology and physics relate. Now, physics and geography are yet another discipline that we have to discuss. Now, we want to relate the two in terms of the instruments used in the weather station for weather focusing and how these instruments are developed. In weather forecast, a geographer uses a barometer, wind gauge, which are instruments developed by a physicist. So all these apparatus are developed by a physicist, and how they work can be explained by the laws and the principles of physics. So you see here, geography is closely related to physics in that it actually borrow and make use of the apparatus that are developed by physics in its own operation. Like this apparatus that we have here, we have a thermometer, we have a rain gauge, an anemometer, hygrometer, we also have snow gauge. All these apparatus are developed in physics and then applied in geography to measure the weather conditions. So that's the relationship between physics and geography. The other one is physics and agriculture. Now, how is physics related to agriculture? We will base our explanation in terms of the instruments used in agriculture as a field. And now, this is how these ones relate. In agriculture, the water sprinkler, insecticide sprayer make use of the principles developed by the physicists. If you want to use the water sprinkler, you want to use the insect sprayer, how they are able to work, you have to develop this, you have to use the principles developed in physics. For example, water from a sprinkler moves at a very, very high speed. And therefore you realize one of the principles applied here is known as Bernoulli's principle. Bernoulli's principle relating pressure and velocity. When pressure is increased, velocity is also increased. So the speed with which water leaves the sprinkler or a sprayer here will be determined by the pressure that you are applying, so that it also determine the size of water that's going to come out, so that it can be able to work properly. Now here the thing is, physics will be able to develop that principle that can be used to actually be applied in agriculture to spray or sprinkle water. And we have here a sample. This is a farm, and they are actually sprinkling this farm with water. So how this water is coming out of this is only and can only be explained in physics. Then we have physics and history. Now, the determination of age of fossils by historians and archaeologists use the principles developed by physicists. So if you want to determine the age of a fossil, how do you determine it? You can't count physically, but you go do what we call carbon dating. Carbon dating is a concept employed by archaeologists to study the carbon content of organic compounds or dead or fossils, to determine the more the number of carbon content in a fossil, the younger the fossil is. And how to develop this formula to determine the age of a fossil is developed in physics. And actually we can be able to use a graph like the one we have here to determine the half-life of a fossil. This fossil in physics, we call it a radioactive material, and therefore it undergoes a radioactive decay. After a given period of time, this number of carbon particles remain within the fossil, and this is able to tell us the age of that particular fossil. So that one relates physics and history. Then physics and mathematics, these ones, they are like cousins, because physics develop formulas, and these formulas, they are borrowed by mathematics to explain and solve mathematical problems that could otherwise not be solved. So the physicists develop the formulas to work out the weight, calculate the weight of objects, the masses and all that. So accurate measurement of time, distance, weight, use instruments developed by physicists. So if you want to actually measure time, you will use a stopwatch, which is developed by physics. If you want to measure distance, you use a meter rule, and the calibration of the meter rule are developed in physics. If you want to measure weight, you will actually use all those apparatus that have been developed there. So these quantify the dimensions and the quantities that are now applied in mathematics to explain situations. So this one relates physics and mathematics. And this diagram can be able to help us here. Now, like in this case, when an object, this diagram is moving, it has to cover this distance s, therefore change in displacement s, and then we have another object falling down here due to its own weight. So these explanations are based on physics, and to quantify this explanation, we use mathematics, because mathematics formulas are going to be used here. Now the other one is physics and technology. They are related, they are closely related, physics and technology, and physicists search for reliable information and then organize it into fundamental laws and principles. In physics, laws are developed. You do a research, you gather your findings, and then develop the principles and laws that will help explain a scenario or a phenomenon. So, like maybe in a technology, these principles and laws are used by engineers and technologists to design and develop devices and appliances. For example, here we are having, this one is a control room. In this control room, we are having various appliances that are connected. So the working and the connection behind this one is explained by the principles and laws that are developed in physics. So these ones relates physics and technology. So out of all these explanations, you have been able to learn that physics closely relate with other subjects and technology. They actually, we cannot separate the two. They are closely related. Now, let's move to career opportunities in physics. What are some of the career opportunities that you can pursue once you study physics? Now, we can become laboratory technologists if you study physics as a subject. You can also become or go to the mapping and surveying field. You do mapping and surveying is yet another field that you can do in physics. The other one is engineering. You can become an engineer if you study physics. You can also become a teacher. I'm a teacher of physics because I studied physics, so you can also become one. So these are some of the career opportunities that you are likely to get if you study physics. So still on the careers, laboratory technologists, this is an individual who works in the lab, do the analysis and all that to come up with the data that can be explained and be able to develop some of the laws and the principles and also make conclusions. So this individual works in the lab and he requires the knowledge of physics for him or her to do this work. So like here now, this individual is in the lab doing an experiment here to collect the data which will be analyzed to come up with the findings that are very, very important. So for you to do this, one, you are working with the apparatus. Do you know how these apparatus work? You have to understand the working of these apparatus, and therefore physics becomes important for one to become a laboratory technologist. The other field is mapping and surveying. So you can get in the field of mapping, and then here we have a map, we have a road. So actually they're doing surveying here on this particular road. So how this apparatus or instrument works to do this work here, you can only explain it when you relate it with the principles of physics. A surveying, maybe you do the mapping. You do the mapping of a given region, you want to get this place and all that. You might need the directions. So physics becomes very important when it comes to this. The other area is engineering. The study of physics can actually lead one to become an engineer. Now, like here we have one. Here, these are the engineers. Yeah, this one, from the photo, we have one with a plan here. Then we have an electrician who has done electrical engineering here. These are yet other areas that you can venture into when you study physics. You become engineer. Then you become a teacher. when you do physics. And then here we have teachers. In the first setup, a teacher is in the lab explaining to the students on how to conduct a simple experiment. You see the apparatus there. So he's guiding his students on how to conduct an experiment. On the second diagram, a teacher is on the board now explaining some concept that students should apply. So you can also become a teacher when you pursue and study physics. So up to there, we come to an end of our lesson. And before we call it a day, you will attempt these questions at home, and in the next lesson we shall look at them. You explain the relationship of physics to other subjects and technology. That's the first assignment you have to attempt. Identify career opportunities related to physics. So that's the second assignment that we'll have to attempt. These are the two assignments that you can attempt, and I can get your feedback through the number 40007 or on our Facebook page. Up to there, I've been your teacher, Benjamin Makanda, and until next time, stay tuned to Lesson2. Thank you very much.